The 20-foot Class 1 Division 2 space is applicable to the gas pumps. This distance is measured from the pump itself. The arrangement includes a 90-foot pier with a gas pump at 30 feet, a diesel pump at 35 feet, and another gas pump at 80 feet. There is an unclassified space of a few feet between the diesel pump and the gas pump. The proper installation of electrical systems in potentially hazardous locations, such as those found at marinas with fuel dispensing equipment, requires careful consideration of the National Electrical Code, or NEC, and specifically Article 514, which addresses motor fuel dispensing facilities. Installing additional 120 volts, 30 amps twist lock outlets and the pier necessitates adherence to these regulations to ensure safety and prevent potential hazards. The use of rigid metal conduit, or RMC, or intermediate metal conduit, or IMC, is a common practice for providing a robust and grounded electrical raceway system, particularly in environments where mechanical protection and resistance to corrosion are important considerations. When transitioning from a polyvinyl chloride, or PVC, conduit run underground to RMC or IMC, it is important to ensure that the connection is properly sealed to prevent the ingress of water or other contaminants. This is crucial for maintaining the integrity of the electrical system and preventing corrosion or other damage to the conductors. The sealing requirements for conduit entering or leaving a hazardous location are detailed in the NEC. A Class 1 Division 2 location refers to an area where flammable gases, vapors, or liquids may be present in the air under abnormal conditions. These conditions might include accidental spills, leaks, or equipment malfunctions. The NEC defines the extent of these classified areas around fuel dispensing equipment to minimize the risk of ignition. In the context of the described pier arrangement, the 20-foot radius around each gas pump defines the Class 1 Division 2 area. This means that any electrical equipment installed within this zone must be suitable for use in a hazardous location or be installed in a manner that prevents the ignition of flammable vapors. The presence of a diesel pump introduces a different set of considerations. Diesel fuel has a lower volatility than gasoline, meaning it is less likely to produce flammable vapors. As a result, the area surrounding the diesel pump may not be classified as a hazardous location, or the extent of the classified area may be smaller than that for gasoline. The NEC provides guidance on determining the appropriate classification for areas around diesel fuel dispensing equipment. The open and classified space between the diesel pump and the gas pump is significant because it represents a zone where the requirements for hazardous location equipment do not apply. However, it is crucial to accurately determine the boundaries of the classified areas to ensure that any electrical equipment installed in close proximity to these areas meets the necessary safety standards. When installing electrical outlets on the pier, it is important to consider the location of the gas pumps and the extent of the Class 1 Division 2 areas. Any outlets located within these areas must be explosion-proof or intrinsically safe, or otherwise protected in accordance with the NEC. Additionally, the wiring methods used to supply these outlets must be suitable for use in a hazardous location. This may involve the use of sealed conduit and explosion-proof fittings. Grounding is another critical aspect of electrical safety in hazardous locations. All metal conduit, enclosures, and equipment must be properly grounded to minimize the risk of electric shock and to provide a path for fault current to flow back to the source, which will cause the circuit breaker to trip and de-energize the circuit. The NEC provides detailed requirements for grounding electrical systems in hazardous locations. The marina operators plan to add 2 more 120 volts, 30 amps outlets, and the pier requires careful planning and adherence to the NEC. Firstly, determine the exact location of the new outlets in relation to the gas pumps and diesel pump. Secondly, determine the extent of the Class 1 Division 2 areas around the gas pumps based on the NEC requirements and the specific characteristics of the fuel being dispensed. Thirdly, select electrical equipment and wiring methods that are suitable for use in the hazardous locations. Fourthly, ensure that all conduit and enclosures are properly sealed to prevent the ingress of water or other contaminants. Fifthly, ground all metal conduit, enclosures, and equipment in accordance with the NEC. Sixthly, inspect and test the completed installation to verify that it meets all applicable safety standards. The NEC provides tables and diagrams that illustrate the extent of classified areas around fuel dispensing equipment. These resources can be helpful in determining the appropriate classification for different areas of the pier. It is important to consult these resources and to seek the advice of a qualified electrical inspector to ensure that the installation complies with all applicable codes and regulations. In summary, installing additional electrical outlets on a pier with fuel dispensing equipment requires a thorough understanding of hazardous location classifications and the NEC requirements for electrical installations in these areas. By carefully planning the installation, selecting appropriate equipment and wiring methods, and adhering to all applicable codes and regulations, it is possible to provide safe and reliable electrical service to the marina. The presence of gas pumps necessitates careful adherence to the National Electrical Code, or NEC, Article 514 concerning motor fuel dispensing facilities. The key point is the application of the 20-foot Class 1 Division 2 area surrounding each gas pump. This classification dictates the type of electrical equipment and wiring methods permissible within that zone. Since the diesel pump has a lower volatility, it may not have the same classification, thus creating the unclassified space. Any new electrical outlets installed must meet the stringent requirements for hazardous locations if situated within the 20-foot radius of the gas pumps. Proper grounding, sealing of conduits, and the use of explosion-proof fittings are critical safety measures. Always consult the NEC and a qualified electrical inspector to ensure compliance and prevent potential hazards. Understanding the NEC definitions of Class 1 Division 2 locations is crucial. These are areas where flammable gases, vapors, or liquids may be present under abnormal conditions such as leaks or spills. The 20-foot radius is a standard guideline, but local codes and specific site conditions may influence the classification. The unclassified space between the pumps is significant because it allows for the use of standard electrical equipment, reducing costs and complexity. However, the transition from the unclassified to the classified area must be carefully managed with appropriate sealing and explosion-proof measures. The type of conduit used, whether RMC or IMC, must also be suitable for the environment. These conduits provide physical protection and serve as a grounding path. Remember to ground all metallic components to minimize the risk of electric shock and to provide a path for fault currents. In the case of adding two 120 volts, 30 amps twist lock outlets, determine if their intended locations fall within the Class 1 Division 2 areas. If so, the outlets must be explosion-proof or intrinsically safe. The wiring feeding these outlets must also be suitable for hazardous locations, often requiring sealed conduit systems and explosion-proof boxes. The NEC provides detailed guidance on selecting the right equipment and wiring methods for these environments. Pay close attention to sealing requirements. Seals prevent the migration of flammable vapors through the conduit system. They are typically installed at the boundary where the conduit enters or leaves a classified area, as well as near any explosion-proof enclosures. The selection of sealing fittings must be appropriate for the conduit type and size. Grounding is a fundamental safety requirement. All metallic conduit enclosures and equipment must be properly grounded to provide a low impedance path for fault currents. This helps to ensure that circuit breakers will trip quickly in the event of a ground fault, minimizing the risk of electric shock or fire. The NEC specifies the grounding requirements for hazardous locations, including the size and type of grounding conductors. Consider the environmental conditions on the pier. Exposure to saltwater, sunlight, and physical damage can degrade electrical equipment over time. Select materials and equipment that are resistant to corrosion and designed for outdoor use. Regularly inspect the electrical system for signs of damage or deterioration, and perform maintenance as needed. Review the pump arrangement to determine the exact distances between the pumps and the proposed outlet locations. A detailed site plan can help visualize the hazardous areas and ensure that the new outlets are installed in compliance with the NEC. Consult with a qualified electrical engineer or inspector to review the plans and ensure that all safety requirements are met. It is always better to err on the side of caution when dealing with hazardous locations. Understanding the implications of installing electrical equipment near gas pumps is essential for ensuring safety and preventing potential accident. The 20-foot Class 1 Division 2 space is a critical factor in determining the appropriate electrical installation methods. By adhering to the NEC and consulting with qualified professionals, you can minimize the risks associated with hazardous locations and provide a safe and reliable electrical system for the marina. Proper planning, equipment selection, and installation practices are key to a successful and safe project. The NEC is a complex document, and it is important to stay up to date with the latest revisions. Local codes and regulations may also impose additional requirements. By staying informed and working with qualified professionals, you can ensure that your electrical installation meets all applicable standards. The NEC provides tables and figures that illustrate the extent of classified areas around fuel dispensing equipment. Use these resources to help determine the appropriate classification for your specific site. Remember that the classification is based on the potential for flammable vapors to be present, not in the actual presence of fuel at all times. Even if a fuel spill is rare, the area must be classified accordingly. The presence of the diesel pump does not necessarily eliminate the hazardous area. While diesel is less volatile than gasoline, it can still release flammable vapors under certain conditions. The NEC provides guidance on determining the appropriate classification for areas around diesel fuel dispensing equipment. The unclassified space between the pumps is a valuable area because it allows for the use of standard electrical equipment. However, it is important to maintain a clear separation between the classified and unclassified areas. Avoid placing any electrical equipment in the unclassified space that could potentially create a spark or arc. This includes switches, receptacles, and junction boxes. When running conduit through a classified area, it is important to seal the conduit to prevent the migration of flammable vapors. Seals should be installed at the boundary where the conduit enters or leaves the classified area, as well as near any explosion-proof enclosures. The type of seal you use must be appropriate for the conduit type and size, and it must be installed according to the manufacturer's instructions. Grounding is essential for safety in hazardous locations. All metal conduit, enclosures, and equipment must be properly grounded to provide a low impedance path for fault currents. This helps to ensure that circuit breakers will trip quickly in the event of a ground fault, minimizing the risk of electric shock or fire. The NEC specifies the grounding requirements for hazardous locations, including the size and type of grounding conductors. Consider the potential for corrosion when selecting electrical equipment for use on a pier. Saltwater and other corrosive substances can damage electrical equipment over time, leading to equipment failure and potential safety hazards. Select equipment that is designed for marine environments and that is resistant to corrosion. Regularly inspect the electrical system for signs of corrosion and perform maintenance as needed. The marina operator has a responsibility to ensure the safety of the electrical system on the pier. This includes providing adequate training to employees on the hazards of electricity and the procedures for operating electrical equipment safely. It also includes conducting regular inspections and maintenance to identify and correct any potential problems. Remember that electrical safety is everyone's responsibility. By following the NEC and working with qualified professionals, you can help to create a safe and reliable electrical system for the marina. The 20-foot Class 1 Division 2 designation around the gas pumps establishes a critical safety perimeter, necessitating the use of specialized electrical components and practices to mitigate the risk of ignition in potentially flammable environments.